Hi all, this is Aditya and today I'll talk about LLM names. When I first started working with LLMs, the names were all so many and so confusing. They all looked something like this. To my untrained eyes, they all looked the same or looked very different. In this video, I'll try to simplify the naming of LLM and make the understanding of the names intuitive. Knowing this will put you in the top percentile of people who talk about LLMs. Now, let us pick this part by part and try to understand. The first part is Meta, and that's the company name. Other notable examples, Google, Microsoft, and Alibaba. Many a times, the name of the company is skipped because the family of the LLM itself is a giveaway about the company that created it. And that's our next part. Knowing the family names will help us choose our LLMs better. Maybe that requires a video of its own. So Meta, it's LLM. Google, it's Gemma or Gemma. Microsoft, it's Phi or Phi. Alibaba is Qwen, and so on. The next part is the version. Higher the version number, better the model is. Duh, that's what versions are for. From now on, it starts to get a little complex. The next part is about parameters. Here it says 8B, B stands for billion parameters. You will see numbers like 0.5B, 7B, 70B, 120B, and so on. These parameters indicate a model's capacity to learn patterns. Higher the number of parameters means that a model can understand a lot more complex relationships because it has the capacity to learn more patterns. But then generally higher number of parameters will mean better models, but then architecture, the kind of training of data, the optimization, all these contribute to performance and not just a parameter count. This is all good, but then look at this name. But even before we talk about this name, here models that don't represent precision basically are called as full precision models. That means that it uses floating point numbers to arrive at precision. Models that don't represent precision numbers are generally considered as full precision models, FP32 or FP16. So that means that it uses 32-bit floating point numbers to represent precision. FP32 models are generally very large and unwieldy. So for all practical purposes, FP16 itself is considered as a full precision model. Let us come back to this model. So after representing the parameters, now it has something called as Q4. These Q4 models, as against a full precision model, are called as quants. Q4 models are quantized models where it uses a 4-bit discrete bins to store weights, as against a 16-point floating point, almost an analogous representation of numbers when we look at a FP16 model. So that means that we give away a little bit of precision, but then this comes with advantages of advanced memory and quick decision making. For a lot of use cases, this kind of a loss of precision will still be okay while working with a few of your use cases. And the use case should decide whether you pick a full precision model or you pick a quantized model. Some other notable examples are Q2, Q4, Q8. That means a 2-bit or a 4-bit or a 8-bit. As you keep increasing the number of bits, you are very close to a full precision model itself. So that's why these are the only numbers that you will most probably see. Beyond quantization, we have a quant variant. _0, _1 are all older style quant variants, but then _k are called as k quant variants, and then _k_m and k_s are like medium and small quants. While Q4 represents quantization, that means how many bits, and it talks about what kind of a compression, but a quant variant, which is _k_m, talks about how smart the compression is. The next is the format. GGUF, Safe Tensor, NVIDIA, so many such formats. When you look at a model which says it's a GGUF, that means that a lot of the files are combined to a single file representation, and these GGUF models will run on CPU. If there is an optional GPU associated, then it can transfer a few of the layers to the GPU for faster performance. If you want a full precision to run on an excellent hardware which has multiple GPUs, then you are better off choosing Safe Tensor or NVIDIA models. Now, putting it all together, just by looking at the name of a model, we will know its company, the family, the version, parameters, what kind of a precision, what kind of a quant variant, and what format it is. So understanding this will help you choose your LLMs a lot better. Hope this made your learning curve a little smoother, and thank you for your time. I'm signing off with this.